So can anyone hear me? Okay. So this week we are what did you do last week? Let's start on the okay, you did on the launch in sensitive contract and the event about Starknet. So this week we are looking at advanced smart contract development in Cairo on Starknet. So the main things we are going to be treating this week, I divided them into three. First of all, we're going to be treating components and composability in Cairo. And then we are going to be talking about cross-contract interaction, like interaction between two contracts. We're going to be looking at some open Zeppelin components. And then at the end, we are going to be building open same contract. No, I'm not projecting it. I'm just telling you what we have for this week. And I hope everybody is prepared because this week we are going to be visiting the competition together. I'm going to be doing less projecting and more interactive. You understand? The slides prepared for this week are very minimal because they don't need to be too much. Like this week, I assume we are waiting three contracts already. So our next thing is to have experience. Am I correct? Very good. Okay. Now, okay, oh wait, you said you can't see my screen. I'm actually projecting, just not slides. Can you see the screen? Can anybody
Now,
see the
because we can see, I can see the screen. I can see the screen. I can see the screen.
screen? Okay, just give me a few minutes. So especially okay, how many of us here write? How many of us here code regularly? I'm sure there'll be a lot of us here that code regularly. Whether you are just beginning or you are doing this from other chains. Right? There are sometimes that you find it that sorry across multiple code bases or across multiple front ends, whatever you're building, you find yourself repeating some kind of code. In the case of smart contracts, there is some logic. There are some things that you want to add, you want to add to your smart contract. you find that you just repeat this code every time. Like every time you build a new smart contract, you write the same thing over and over again, the same pattern. Even if the entire thing is not the same pattern, there is a part of it that it's the same with a lot of other contracts that are written. Do you understand? Can anybody relate? I believe you can. One thing about code is that they always say you should keep a code dry. The full meaning of dry is don't repeat yourself. So if there is a way, if there is a way to avoid doing the same thing over and over again, then for optimization, just do it once and release it. In React, in something like React, that's what the concept of components from. In JavaScript and some other languages, there are some processes that you can just abstract into functions that you can actually reuse across different places. Do you understand? And besides that, if you can, another is of functions, and in this case, components also work like that, is that you can make your code base much cleaner by taking some things away and just making your code more readable, high level. You don't need to always see the details of what's going on. You just want to see at a high level what you are doing. So that's where the concept of components comes to play. Do you understand? So components and composability on Starknet. Components. Um okay, I'm going I told you it's going to be less it's going to be less about the slides and more about interaction and be relating to what I'm saying. If you noticed in the last class we had 2 weeks ago, right? When we said that there is a storekeeper. Who can remember when I wrote that? Anybody? Am I talking to myself? Okay. So there are some actions that we were saying only the storekeeper should be able to perform, right? There are some actions we were saying only the storekeeper should be able to perform, like adding books, removing books. There are some of those things like that. The meaning of that thing that we just did is these particular functions were giving access to only the owner. You understand? Hello, can anybody hear me? Please, I need your responses. So, so there's shared logic like that possible. Yeah, we can go to another contract now and say this one is how what should I say this one will be? Let's say this one is a payroll and we need only the owner to be able to send payments to his employees. How are we going to do it? We are going to have to start coming to each functions again and saying let owner equal to get caller address. If that kind of thing. So that was like very repetitive, right? And that way your code is not dry. So in order to make your code dry, in some cases, you need to use components. That's where the concept of this is just an example, but that's where the concept of open Zeppelin's ownable components came into play. I'm not going to pull it up here. So I'm sure some of us have heard of open Zeppelin. They provide components. one of the components that opens the belief links is sorry, hold on. One of the components we have using opens the belief is the ownable components. Now, these components can be taken and implemented inside any contracts. And then we are not going to have to write all those functions. Okay. So let's go from the top. Developing contracts with shared logic and storage can be difficult or error-prone or repetitive, as the same functionality needs to be implemented in each contract. But provide a solution to this. We can abstract some of the logic that we know that we need in multiple contracts. We can write it in one place and then use it wherever we need. Components are like Lego blocks. They enhance the contract by plugging in modules such as ownership, or there's actually a component for ERC20 token. Unlike contracts, components are not standalone and cannot be deployed separately. They are just abstraction of logic. They are not full contracts. So whenever you want to deploy it, you have to put it inside the contract. So instead, their logic becomes part of the contract right when it's embedded. So the component is very similar to smart contract in that it contains the storage, it can emit events, and it has both external and internal functions. The only difference between a component and a contract is that you cannot deploy a component. You have to embed it within a contract. Is anybody following me? So we're just going to go straight into coding. And okay, let's see what component should I implement. Let's look at something like ownable components. Okay? Although it's instead of writing some kind of component itself, it's better to just import from OpenZKM. But let's put an ownable component. Okay. So this is the contract we use for using us. This Skillup Bootcamp. I hope everyone here can remember. Oh, it's like you can't see my screen. Sorry, hold on. Let me increase the size. Can you see my screen now? Okay. In these contracts, right, we store the storekeeper address. And in some of these cases, like these 3 lines now, what these 3 lines are supposed to do is that it's supposed to say only the storekeeper can carry out this function. Same thing here. That's the same thing. This line goes. It's just these two functions in this case. But when you are writing real world smart contracts, we are going to have many cases where you are going to need to close functions outside of like let only the owner be able to call a particular function, such as in things like things that concern money, for example. There are many use cases for this. Also, something like an ERC20 contract now. We know that an ERC20 contract has a particular set of functions that it must implement. So it does not make sense if everybody in the world is repeating this particular logic in their code. It makes more sense that we have a general component and anybody that wants to use it can just import that component and use inside their contract. Is anybody following me? Okay. So I'm going to create a folder here. I'm not folder. Then I'll move this storekeeper design, the bookstore dot Cairo. I'll take everything here and put it here. Then I'll come back to my lib.cairo and expose it. Oh, okay. So what I've just done is that I've said that there is a folder in this code base called contracts. That's this folder. And inside there is a file called bookstore. That's just what I've done. Same way. Whenever you are writing code and you are not putting everything inside the lib.cairo, you have to use this pattern. If not, the compiler is not going to recognize anything here. The lib.cairo is your entry file. So um, so inside here, the first thing, just okay, let me come back to this lens. Just like a contract, right? So a component has an interface, it has a component has an interface. I mentioned that a component is exactly like a contract, except that it cannot be deployed. And then the decorator for it is not Starknet contract, it's Starknet component. Then the implementation block is also a bit different. Sorry. There's the stuff. There's the stuff. So I'll come to the interface. So in a reusable component, in a component where I want to make sure only the owner has access, right? I just want to have a function that will assert that is only the owner that is calling about this function. So assert only owner. And I want to return a boolean. So if the owner is the one calling the function, it will return true. And if it's not the owner, it will return false. So I come up here, use Starknet contract like this. Mind you, please remember to do this when you are structuring your code base. Always remember to come to your lib.cairo to expose everything. If not, these compiler suggestions and everything, you are not going to get any of them. Then I'll implement just two functions here. Sorry?
You said remember to.
Okay. When I created a folder called components, I put it within this lib.cairo, and then everything inside it I exposed it on this enable file. That was it. And inside this contracts folder, we have a bookstore file. That's what's here. Do you understand?
No, not yet. I was thinking you're going to put something like use contract slash bookstore stuff so that, well, I can't see the use here on this lib.cairo.
The use in this lib, if I remove which one is lib.cairo, the compiler is actually not going to see any of this again. So if I build what I have here now, it's only going to know about what is inside this component folder. Do you understand? Do you understand? It's your entry file. So everything that you're using has to be made known inside this file. Do you understand what I'm saying?
Yes, I understand what you're saying, but the lib.cairo file, where is it pointing? Where is it pointing to this enable.cairo and this bookstore.cairo? Like because I wanted to see something like use create slash contract slash bookstore.cairo. Then I can start seeing this bookstore. But I'm just
you are going to see it when I'm calling the enable within the bookstore. And if I didn't do this, I'm not going to be able to make the code.
Well, I don't know. You can just continue. Let me just. I really don't understand it, but let me just be watching and let me see if I can pick it up.
Just be watching. So I'm going to implement just two functions: assert only owner and transfer ownership. Transfer ownership. Let's see. Only owner. Actually, I'm going to use this. So I think this is my computer interface. Hold on. This is how I choose to do this. So what I'm going to do here, I've implemented the interface. more like I've defined the blueprint for the components. So the next thing is just to, but instead of Starknet contracts, we're going to the Starknet components. Components. Compile I short nothing. Storage. Then I'll define my events. Stored ownership transferred. Now, for new owner, it will be a contract address. Exactly. Which one to like this? Is everybody following so far? Who does not understand anything so far? So it looks identical to a contract, except that when we get here, instead of if it were a contract, at this point we'll do something like ADI and then correct. Then we now have our implementation. Do you understand? We just know what components use. In the components, they have demonstrated this side, demonstrated this side. Oh, actually, this will now finish it. In the implementation, instead of that, what we have is now embeddable as. Now, this embeddable as, this name that we have here, if other contracts want to use these components, this is what they will, this name is what they are going to do. So I'm going to say embeddable as owner. Next one is is anybody following? Then who does not understand anything?
This embeddable as, this was the same thing I was googling this afternoon. I was using ChatGPT at the cloud to understand it. And I did not understand it. And again, you are not talking about it now. So it's like this is what to kill it to do.
I just mentioned
you can just talk a little. Yeah, but I did not like get the picture. Like I just want to just know the picture, not like I want to know like the picture of what it is, like the idea behind it.
See, it's used to mark the implementation as embedded inside the contract. So if you don't put that particular line you are not going to be able to use the components inside another contract. You understand? What it just does is it specifies the name of this implementation when we want to use it in another contract. You get here we use available as enable. Are you following? So when they want to call it exact, when they want to call it in another contract, they will refer to it with this name. Is that okay?
For now, yes, for now.
So then another thing is that instead of having a normal contract, or inside the normal contract, you have something like this here. Is that correct? But that's not how you see some components. Instead, we have this C contract state because it's not a contract itself. It's going to be implemented by a contract. So it's when it's implemented that the contract state is going to be passed to it. It can't refer directly to the contract state. It just has to use something to present it, just like with the interface. So it's are you following me? You will see contract states this, and then you mention the what's it called? You mentioned the interface that it's implementing. So that's what we're going to do now. And actually decide to use T as I used before. I don't use super here. So I'm just going to put and it's shouting at me that I've not implemented all the items. So as a lazy day, open and paste. But again, there's still going to be what differences. Because then, oh, this is what we are going to use instead of using contrast states. This is what we are going to be using inside components. So instead of saying you can't say T contract states, instead you say component states wrapping silicon. How did I let me see. Let me see. Let me spelling. Oh, yes, I missed some. This is what I missed. So this IO label will not just wrap the contract states. It's also going to wrap the contract states. And then I define this twice. So I'm going to change the name of this. Who does not understand what just happened?
Please excuse me. This on your career book, please. This page that you are getting this is exactly it, because I'm seeing chapter 103, and I'm not sure that's what you 103.
Let me send this. I don't like the way it's just one person talking in this place. Who else is following what's happening? Is any other person following what's happening? So I'm going to also implement this. So who does not understand what I just did now? And then in the storage, I'm going to put, sorry, I've not put this ownership transfer, ownership transfer. Owner will be a contract address. You notice there's another difference between this and a contract. There's something as a contract to have that we have not put. You can tell us what it is. Who wants to guess? Should I put one on the table? There is something else. There is something else. Look closely. There is something else initial contract to have that we have not put here. Who can tell us what it is? Nobody. Oh well. Remember that there is a particular function that runs at deployment, but we cannot deploy a component. Do you understand?
That should be constructed.
Exactly. So a component does not have constructor. Instead, what we can have in a component is an initializer. This one is it's a sorry. This one is actually optional to fix. It's completely up to you. But it's not as one of the it's not as one of the external functions. It becomes an internal function here. So that we can call it before we have to call all the other functions. So we are not going to write any interface for it. There is this thing called generate truths. So internal content. Who is not understanding what's happening? Who have I missed? Is just sequentials. So I can put an initializer and here self dot Emma dot write. Emma. Oh, I've not implemented my storage. Why need to use now? So I actually don't need this tree now. When I need them, implemented. Whoa, man. Okay, we are here right now. So what I've done so far, I don't know how many of you are following this. I'm actually not getting any response from anybody except one. But what I've done so far is that what I've done so far is I've written these components from the beginning, right? And then I have written an internal implementation also this one here is an embedded implementation, so we can use it externally. While this is an internal implementation, is meant to be the functions written inside here are meant to be used by only the contracts. So they are meant to be used just here. They're not supposed to have access to them outside. That's why they are called internal contracts. But I've not implemented any of the logic. The response this evening is actually very full. Is anybody following me? It's like everybody now is using note taker and the real person is actually attending this. Please, who is here? Who is following me? Oh, wow. Chance of this guy's the most thing. So inside here, inside here, this transfer ownership is used to make the particular the address supplied here owner, right? So we are going to call the function inside here. So self dot transfer ownership was error. No, wow, let us change it. So hold on.
The error should be from your storage now.
Uh, so this one is free. Alright. Oh, no. Uh, uh, this was the issue. I also forgot to. Do you understand? It must be the same as the contract that is referring. So yes, I'm going to put this as the constructor. So when I want to use this component, let's say I have this contract now that I want to use this component inside. What I need to do is I'm going to initialize that component inside the contract constructor here. So instead of saying self.storekeeper.write, I'm going to now say self.enable. Now after I import that contract as label, then I'll call the initializer of that particular component, and then I'll supply the storekeeper address instead. Do you understand? Do you understand? Since you're the only one for me.
Not really, not really. I'm trying hard to understand it actually.
I said, this is a component, and the point of the component is that it's going to be reusable. Are you following? So when I want to use these components, these ownable components, say I want to use it inside this bookstore, instead of writing to the bookstore's storage itself, I'm going to call this initializer here. I'm going to call this initializer here, right? And then I'll supply the storekeeper so that the address that will be recorded here as the owner is the storekeeper. Do you get? Now, what is the third person? There is a reason. Then in this Cairo book, here they actually used get color address to get the address of the color. But for some reason, I don't. These are actually personal choice. I don't like using get color address to get the address of the color when the function I'm dealing with is a read function. I know that on the high level, that's when I'm using it within the contract, there's actually going to be a color, but it can cause unexpected behavior. So how I choose to do my own is I'm actually going to supply the address of the color as an argument. So what I'm going to do is let owner be equal to self.owner.image. And now what I'm going to return is a boolean. So I'm going to return owner equal to color. Do you understand this line? So if owner is equal to the color, it's going to return true. If the owner is not equal to the color, it's going to return false. Do you understand?
But it should be an if now. It should be an if. You just declared it. It should be
No,
an if.
no. This line here, owner equal is a comparison. And a comparison always returns either true or false. So there is no need for something like this. If this comparison is true, the boolean will be true. If it's false, it will be false.
Yes, I
So our need statements are actually very redundant.
mm,
Another thing I can do is another thing I can do is instead of putting this here, I can write an internal function assert only components with some contracts. And then I'll put this here. And then I'll come inside here and see cell dots. Assert only on or color. So what means to provide it here? It's official. I don't know how to write Cairo again. I want to do my different in this. Okay. Let me just relax. Oh, which one is it? The reason I wanted to do that one before is here I can actually get collaborators. Yes, since this one is the right function, I'll just go up and implement it. Get collaborators. Okay. Assert cell dot color dot width is equal to color log collected. Okay. Then if the owner is the color, I'm going to change the owner so that only the current owner can transfer ownership. So these are the two functions that I've implemented. You understand? The component is complete. The next thing is to integrate it into my function. Now, so I'm supposed to integrate it here. And this is where you now get your space components, enable components. Do you follow? Very good.
Now, excuse me, please. Now that you've
Yes, yes.
now written it at this that file, can you please go back to your VS Code? I'm
Okay.
just trying. There's a conflict now in my head now.
Yes,
You've now written it in this bookstore.carry.
yes, yes,
Why did why did you God, on your lib.carry, that is your main entry point. But
yes,
what you did was you just declared the modules and you made them
yes,
public.
yeah.
But this is your bookstore.carry now. Why are you now writing this use? I was thinking that the use is going to be at the lib.carry because it's the main entry point. Oh my God, I don't
No,
understand.
the the end this lead of Cairo now. Declaring it inside this lead of Cairo makes it available anywhere. Like if I comment this out, the crate cannot see it again. And when I come to this bookstore, see identifier not found. Do you understand? So the entire code base is defined by what is inside lead.cairo. Your compiler does not care about any other thing. It's only when lib.cairo tells it go to this folder and look for this thing that it will go to that folder and look for that thing. Else, what you are waiting does not matter. So So, and the next part is using a component inside a contract. So this is it's just as easy as this. First of all, you know, just use the component keyword, give the path, name the storage and the events, and then you put the implementation there. You can make the implementation public or you can make it private. If you want to make it public, you are going to use the ABI embed this here. So in this particular one now, this ownable implementation is public, while the internal implementation is not public. And I don't know if I mentioned it in the last class, a contract can actually have multiple implementation blocks, but you can see it. So we are just going to use the component. What is this? So components, the path, only two components, storage, enable, and the events. We are going to call it enable events. Now you have to come to the storage. Do you understand what just happened? So the storage of this enable component, we are putting it inside here. Okay, that's giving us another error. I was trying to remember this actually. So before you put a component storage, you actually have to use, you actually have to put this sub storage reserve. And then it's know that it's a component storage you are using. There is something like that for events too, but the compiler is going to tell me events, level components. Okay, hold on. Exactly. Compiler is supposed to shout at oh, it's saying, oh, I forgot to do something. Just imagine my ignore the mind. Starknet. Then it is almost complete. Then you can see, wait, before I continue, are you following so far? Ebuka, hello. Chukwuebuka. Same thing we have been doing right now.
All right, all right.
And this is going to be popular. Let's hold on. You saw what I said that time. It's the name that I had to use, it's the name that I put here. That's why it gave that error. So when I changed it stopped shouting. Do you understand? Can you hear me? So I have to use the name that I gave it in this line, which is did I know which song? Oh, I did not. Oh, it's in the bottom. Then lastly, I'll go to the constructor. And this line here will become self.enable dot initializer. And I'm supposed to initialize it with the storekeeper. Do you understand up to this case? Hello. Do you understand? Do you understand what I just did now? Chukwuebuka, anybody, do you understand what I just did now? Oh, apparently it's not, but it's anybody in this class right now. Huh? Okay. Don Bosco, are you following everything that has been done in this class? Or should we just meet on Wednesday? Okay. I'm guessing we are not disposed to this class. So let's just meet again on Wednesday. I hope we're better displaced for class that time. I'm going to go over what I did today, and then we're going to look at using components from OpenZeppelin and other things that I mentioned that we're going to treat in this week. So that brings us to the end of this particular class. And I'm going to see you next. Good night.